Welcome to the second part of the podcast on the world of IoT and its future. We're talking with Dr. Timothy Chou, lecturer at Stanford University. So stay tuned. So I think one thing that I want to talk to you about is Cisco recently released a survey result that said 3/4 all IoT projects are failing. What are your thoughts on that?
Yeah, I actually thought this was interesting that they released this report, and they went further with this. If you go read the report, and if you're interested in the area, they go further and they say, well, part of the problem is a lack of interest, with leaders failing to buy into IoT. And the Cisco CEO said, well, we need to build an IoT architecture that allows you to go beyond, right, the 26% or 25% of people that have adopted. So he's basically making an argument that this is a technology failing. And my point of view is this is not a technology issue, right? This is really a business model issue, right? And I'm going to particularly focus the conversation on the enterprises that make machines, right? Make tractors, make wind turbines, make blood analyzers, right? Make forklifts. And, for those guys, they've largely been focused on the world of selling you a box, selling you a product, selling you horsepower and torque. And I think without them understanding that there is a new business model in front of them, they're not going to invest, right? It's going to just be a lot of fun that some IT guy got to have in connecting these or applying some machine learning. They're not going to really go to deployment. And I like to start those guys, the guys that make machines, with fundamentally having them realize that their machines are increasingly hunks of software. And the example that I use, which is coming out, I don't do a lot of stuff in consumer, but the automobile world is kind of sitting in between. If you look at the 2016 Porsche Panamera, it had 2 million lines of code in it. The 2017 has 100 million lines of software in it, right? It's not just the world of cars, right? The latest tractors have 4 million lines of code in it. The latest combine harvesters have 5 million lines of code in it. Drug infusion pumps are, I'll say, getting into the 200,000 lines. The MRI scanners are probably already way beyond 7 million lines of code, right? And the ability, I think, which we already see if you go open up a Tesla, is the ability to change your product, build new features, et cetera, which software lets you do, just begs that you put more software, you define your machine by more software all the time. So when I spend time with those guys, I say, if software-defined machines are the future, then what can you learn from, I'll call it my world, which is the software world? What are the software business models, and how can these be used to generate more revenue and more margin for your business? So let me take you through what are the software business models. So there fundamentally have been three. The first is we say, oh, I'm going to sell you a product, and ERP, middleware, databases, whatever, and a disconnected service. That's model one. Model two is I will connect to your machine, and I will provide you assisted services. I'll help you with managing the availability or security of your ERP, your CRM, your whatever. And finally, right, if I can help you do that, if I can assist you in doing that, then I can do it for you, right? And so what you know of as software as a service, or what I'm going to call delivering your product as a service, whether that's Salesforce or Workday or NetSuite, et cetera, right? That's really the culmination of what I term Model 3. And by the way, when I move to Model 3, I can completely change my pricing model.
We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
So let's just dive a little deeper into this. If you look at Model 1, and I tell people, if you're not a student of Oracle, although this is representative of all the existing enterprise software companies, what you realize is that the dominance revenue in those companies is service revenue. In the year before Oracle bought Sun, so this is purely a software company, it did 15 billion in revenue. 3 billion was selling you a new product, a database, a CRM, a middleware, whatever. 12 billion was service revenue, right? 12 billion was service revenue. 80% was service revenue. And by the way, that's recurring revenue. You get it every year. It has a very low cost of sales because I already know who the customer is, right? And the margins are north of 90%. Why are the margins so high? Well, it fundamentally, and people need to understand this, service, and I think a lot of people think service is about break fix, right? We actually did an analysis at Oracle now, this is got 2003. We analyzed 100 million service transactions coming in, whether that was, on the phone and, on the internet, et cetera. 99.9% was answered with known information. This is not break fix, right? So what is that information? I say fundamentally, it's information about how to maintain or optimize the performance, availability, or security of the product, right? It's information about how to maintain or optimize the performance, availability, or security of the product. That is what is service. Service is the delivery of information, right? And once you understand that, right, then you go, well, if I can now connect to the machine, well, I can make my service even more personal and more relevant because I know what, version number you're on. So I can tell you exactly what patch. I know what kind of disk you're running. So I can tell you how to optimize, your cache hits, et cetera, right? So I can make my service even more personal and more relevant and telling you how to manage the performance, availability, or security of your product. And then, as I said, ultimately, if I can do that, then I'll just do it for you. And that is what we have seen as product as a service. And by the way, when I get to that business model, I can shift. It's no longer product plus a service. I shift to, right, per seat, right, per transaction, or as we've already seen in the world of hardware, per instance pricing, right? Okay, so that's a little short tutorial on what software product business models are like. Let's now bring in the world of hardware, or into the world of things. So I always say to people, well, why is it, you should wonder, why does GE care about this, right? Why do they like to talk about the industrial internet, right? And I go, it's really easy. If you go pick up their 10K, their financial statement, you'll see it right away. They operate today in a 50-50 model. 50% of their revenue is product, selling you a jet engine, an MRI scanner, a locomotive, whatever, right? 50% is service, disconnected service, by the way, on that jet engine, right, MRI scanner, et cetera. And furthermore, they sign multi-year contracts for delivering that service. And so they actually report that. And, last year I was 250 billion in revenue. Now, if you think about it, if I can make my service more about information delivery and not human labor, well, my margins go up. And by the way, if I can move to an 80-20 model, not a 50-50 model, I just added how many billions of dollars worth of revenue to my business, which is recurring and high margin business, right? Just to not make it about GE, there is a European manufacturer of elevators. They operate in a 50-50 model today. 50% of the revenue is selling you an elevator, 50% is service on that elevator, recurring revenue. 2008, we all know there was an economic downturn, and so their revenues went down, but their margins went up. And why? Because, and most guys who make machines know this, their product margins suck, right? Because they're increasingly being commoditized. Yes, in this case, their product margins suck, but their service margins don't. So even though their revenues went down, right, the corporate margins went up. So I say to these guys, look, why don't you build, and this is now bringing up business model 2, why don't you connect to those machines that you have out there and now combine the information and knowledge you have about those machines in your IT systems. By the way, your call tracking systems, et cetera, contain a lot of information about what is going on in the customer, combined with the machine data out there, the sensor data out there, and deliver to the customer, right, the ability to improve, optimize, maintain the performance, availability, and security of that machine, right? Combining the so-called IT data and OT data to deliver a connected service. This is not about break fix. I'll tell you, this was probably late last year, I met the CEO of a large semiconductor machine making company. They make wire bonding equipment. I said, well, how many machines do you have in the field?
We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast.
He goes, oh, we have 50,000 machines in the field. I go, wow. I said, how much service revenue do you generate? And he goes, 0. I go, I could guess why it's 0. It's because you tell everybody service is break fix. And the guy just spent $250,000 on the machine and goes, well, I hope it doesn't break. Right? You are not going in there and selling them that you have the information on how to maintain or optimize the performance, availability, or security of those machines. And by the way, and I did this as a back of the envelope exercise, I tell guys who make machines, I know how to double your revenues and quadruple your margins. Because, this is a simple case study, if they have 4,000 machines in the field, so that's not a whole lot of machines. If the list price of those machines, the selling price of those machines is $150,000, a lot of machines are way over $150,000. And let's just make an assumption that they sell just 500 new machines a year. Then what that implies is that in the current model, which they sell no service, they will generate $75 million in product revenue this year. And oh, by the way, next year they have to go find another 4,000 machines to sell, right? And I look at them and I go, guys, look, if you just, and remember I made the point, or maybe I didn't make the point earlier, in the Oracle model, we charge people in effect for the disconnected service 2% of the product price per year, 2%, right? For that information. If I only charge you, and I just did this, 1% per month, right? Because I know it's new and they're not used to doing this. I go, look, and you go after your installed base, you could now generate a service business which is equivalent to your product business, which is much higher margin, recurring, every year you get it, recurring revenue with a lot lower cost of sales if they were to go build, service products, digital service products, not break fix products. I think that opportunity is in front of them, every last one of them, to go do this. It's an incremental revenue on where they are today. But I will tell you there's even something more important, which is if you could build this business, by the way, what do you know? I now know how to manage the performance, availability, and security of these machines, to optimize them, to improve, right, the availability of them, et cetera. If I know how to do that, then I go, well, what's the next step? Well, it's I'll do it for you. Tell you a quick story here. There's a company out there called New York Air Brake. New York Air Brake builds an application that connects to locomotives. They connect to it, they collect data from it, they learn on it, they provide assistance to the train operator, when to speed up, when to slow down, right? Save fuel costs. They actually save $6 million a year for Norfolk Southern. But again, if you can tell the guy what to do, well, you can do it for them. And this year, they're going to run an autonomous train from the north of Australia down to Perth, right, dragging iron ore, which
Wow.
clearly dovetails you into business model 3, which is delivering the product as a service. I look at people, I go, well, let's talk about the machine called a car. If I was going to deliver a car as a service, well, what would my pricing model be? Well, it would be, per ride, right? It's obvious it would be per ride pricing, right? I go, well, we already know guys doing that, right? They're called Lyft and Uber, right? And I point out to people, what is the most expensive thing in that ride? It is not the sheet metal. It is not the gasoline. It's the human, right? By the way, the most expensive thing in delivering software as a service is if you use humans, will be the labor in managing the availability, performance, and security of the product, right? If I'm doing this with hardware, the most expensive thing is the human labor to manage the performance, availability, and security of the server. I will spend a lot of money automating the management of the performance, availability, and security. That's what you see inside every SaaS company, inside every deliverer of compute as a service, storage as a service, is I will automate the hell out of that. Guess why automation is interesting in the car business? It's the same thing. I'm going to take the complete cost structure of the most expensive thing out of it. And by the way, at that point, what am I going to end up with? Well, why would I ever own a car? There's no reason to own a car, right? So this is why it's hugely disruptive in the automobile industry, and why you're seeing people attacking this from from Lyft, from Uber, from Google, from Ford, from Toyota, et cetera, because this is hugely transformational from an economic point of view, and the move to product as a service, which we've already seen revolutionize the tech business. As I said, it's headed into the car business. So all you guys out there who are building, forklifts, blood analyzers, right, combine harvesters, compressors, et cetera, I can tell you what the future looks like. You're already seeing it. So I think it's not the future success of IoT and I think the key player are the guys that make machines, make agriculture, make construction, make power, make mining machines, that they move to 3 business models, start with product plus a disconnected service, connect it and provide more service, deliver the digital service product as a product with a sales force, a marketing group, et cetera, selling it, and drive incremental recurring revenue. You will build all the technology necessary to deliver finally your product as a service. I don't counsel them to jump to product as a service, because I know all the complications with doing that from your channels point of view, your sales point of view, and they'll stop themselves if they try to go too far. If they just build Model 1 and 2, they will be technologically positioned to deliver Model 3 quite rapidly. So I think that's the key right now to more success in the world of IoT, is we got to get the guys who make machines to understand there's a huge revenue opportunity, an ability to, like I say, double their revenues, quadruple their margins by delivering digital service products.
Interesting. Cool. Okay. So let's talk about. We'll resume after a short break. This part of the podcast is brought to you by First Friday Fair, fastest AI-powered way to find your next opportunity. Check out the website firstfridayfair.tao.ai and find your next dream job. Let's get back to the podcast. Like, which businesses would see really the impact, or which businesses should worry about this impact from this IoT expansion or IoT sort of evolution? If you can shed some light there.
Yeah, I like to counsel people to think about the world as enterprises that build machines. So build healthcare machines, build agricultural machines, build construction, build power machines, right? And the guys that build those machines, so Boeing builds aircraft, are different than the guys that use machines United Airlines, the guys that build gene sequencers like Illumina are different than the guys that use them. Hospitals like Children's Hospital, et cetera. So these are obviously related, but they're not the same. So first focusing on the enterprises that build machines, I go, well, what you're seeing today is they realize that in a lot of cases, if they can improve the quality of their service, they're building a better machine. Combine harvesters are an interesting example of this. People may not have thought about this, but if you're harvesting grain, you don't harvest all year long, right? There's a window when the grain is ready, moisture levels, et cetera, where you go out and you harvest it. And so in that window, you want the machine to be available, right? And so if I can now use technology, software, machine learning, connection, et cetera, to improve the quality of my machine to build a better combine harvester, right, it has big implications on the quality of my product to the guy who uses the machine, right? So a lot of people are down this path. How can I improve the quality of service? There's also how do I reduce the cost of the service, right? So some of you may be aware of United Rentals. United Rentals rents construction equipment. They're, I think, just closed the year at $6.6 billion in revenue. They rent, forklifts, scissor lifts, et cetera. If you go look, they actually spend $1 billion a year in maintenance of that equipment, $1 billion. If I can use technology, software, et cetera, to operate more precisely, right, rather than use the old, it's 3,000 miles, I'm gonna, change the oil, but rather change it when it's needed, change it ahead of time. If I can just operate 10% better, 10% more precisely, that's $100 million. And $100 million, it goes straight to the bottom line. So reducing the cost of service for guys is a huge motivator, I'll say, for why do you want to do this. But I've made the point that I think the machine of the future is going to be a bunch of sensors, a bunch of actuators, and a big computer in the middle. And if you want to see a modern version of this, go pick up a Tesla, right? And this is why I think in the world of machines and a Tesla, people know this, right? Every couple of months you get a new feature in the Tesla, right? Well, that never happened in your Ford or your Porsche, right? I mean, nobody ever thought about that. Well, in the world of software, we go, of course this happens, right? You know exactly how to go do this. I actually had the opportunity to do a talk to the 90 CTOs of the Tata Group in India, right? If those who don't know, it's like the hugest company in India that some people say that you can be born, live, and die and only use Tata products, right? So I did this talk. So you may be aware they own Jaguar Land Rover. So I said, the machine of the future is a bunch of sensors, a bunch of actuators, and a big computer in the middle. So later in the day, the CTO, Jaguar Land Rover, got up and said, oh yeah, Tim said, future machines, sensors, actuators, big computer in the middle. He goes, I only wish it were that way. He goes, I have 18 different computer systems in there and none of them talk to each other, right? So the vision is there, I think. And I have said to people, well, if you comprehend that the machines of the future are increasingly software, then the move to business models which echo the business models from the world of software are upon us. GE is very interested in this area as a machine manufacturer because they generate 50% of their revenue as a service business, right? And I will say most companies out there generate, I was just spending time with a construction equipment company. They operate in a 97-3 model, meaning 97% of their revenue is selling them a product and 3% is service, right? So every year they have to go sell again the same amount they sold last year just to stay even, right? So the ability to move to the first business model of starting to sell service, starting to sell digital service products, I think some are way ahead of others, but that is part of their future. They will ultimately connect, and some of the companies out there are much further along in this, in connecting their machines. And if they can connect the machines, they can offer more personal and more relevant service. I've built business models that suggest if I only charge 1% a month of the purchase price of the product, I could double my revenues, quadruple my margins, right, by doing that, by delivering product plus a connected service. And finally, if I can do that and tell people how to manage their security, their availability, their performance, I can ultimately now do it for them and deliver the product as a service. We're obviously seeing the early signs of that in the world of automobiles, where people are very focused on eliminating the fundamental cost in delivering a car as a service, which is the human labor. By the way, to make the point, that's the fundamental cost in delivering compute as a service, delivering software as a service, versus the old way of me being an IT company, or an IT organization. I have human labor managing the performance, availability, and security of the software, of the hardware. If I, quote, hand that over to the guy delivering the product as a service, he is not doing it with human labor. They are doing it with automation, standardization, etc. Same thing, I believe, is going to happen in the world of machines. So that is, I think, the thrust of the future for guys that make machines, and why should they care, right? Let's flip over to why should enterprises that use machines care, right? Okay, I'm going to give you 4 fundamental reasons. The first one is it can lower their consumables cost. I think most people are probably aware of this, that the operating margins of an airline are directly related to the consumables cost, meaning the cost of jet fuel, right? If they can operate more precisely, they can deliver higher operating margins, right? So there are businesses out there where the consumables costs dominate their operating margins. And so if I can operate, as I said, more precisely with my airplanes, et cetera, I can drive higher margins in my business. The one people probably are not aware of is the gene sequencing. The so-called $1,000 gene sequence, $767 worth of that gene sequence is consumables. It's chemicals. And so if I can operate more precisely, I can reduce the cost of gene sequencing, therefore making it available to way, way more people, et cetera. So I'm going to lower my consumables cost, could derive, benefits to people who use machines. If I use these, I call them precision machines, I can deliver a higher quality service. So there's a little story about Duke Energy. So Duke, as some people know, is one of the largest, or the largest energy electricity company in the United States. They have installed a group of machines called synchrophasers out there. Synchrophasers, for the non-EEs out there, measure phase angle at different points in the grid. By the way, measure them 60 times per second. So why do they do this? Because if they can aggregate the data, collect the data from these machines, they can use it to predict blackouts, brownouts, and therefore produce a higher quality service, right, as a user of these machines. I can produce better quality products. So if you look at agriculture or farming, yes, a farmer who uses less pesticides, less herbicides, et cetera, is using less consumables. So that's better operating margin for his business or her business. But by the way, if I'm using less herbicides and less pesticides, I'm creating a better product, a healthier product, right? So again, why do I want to use, precision machines to improve, in this case, improve the quality or the health of the product? And the last one I'll say is I can improve the safety, right? But most people may have never thought about this, but the number one reason why computer systems fail is not hardware, it's not software, it's humans, it's us, it's people, right? We're the number one reason. So if I can automate, if I can take the humans out of the loop, right, I can produce safer systems. And clearly we know examples in trains, et cetera, where it's quite obvious the problem was not the machines, it was the humans. So if I'm operating more precisely, right, I can improve the overall safety. So I think those are all the, reasons why people that build machines should care about the Internet of Things, as well as all the people who use machines should care about the Internet of Things.
Interesting. So, and by the way, thank you so much for walking us through. And it's a very exhaustive. And thank you. I do appreciate you sort of sharing an insight, and it's really, really, really useful. So, what I wonder, like, so we are hearing a lot about machine learning, and we're hearing a lot about artificial intelligence, sort of getting or impacting almost every facets of technology today. What is happening for the AI in terms of the world of IoT? Like how it's getting shifted or impacted in the world of IoT?
Yeah, great question. I think, as I said, I do a lot of public speaking out there, and I tell people, I think everybody, whether you're an IoT or not IoT, you need to get smarter about what's going on here. We are seeing this on the consumer side in a meteoric way. If any of you have not used Google Translate lately, go check it out. I mean, it's amazingly better than a year ago. Obviously, Alexa, Siri are things that we get to see right now, and speech recognition. People didn't think a computer could beat a human in Go for 10 more years, and it happened 2 years ago, right? So the thing I'd like to get the business leaders, technology people should be thinking about this too, is why is this happening? Why is this happening so rapidly, right? When we've all been talking about AI for a lot of years, right? So the example that I like to show how fast this is happening is the ImageNet competition. So the ImageNet competition was started in 2011. So what is this, 7 years ago? Not very long ago. It's a competition between computers and humans as to who could recognize images better, right? So when they started this whole thing out, the humans were 5% incorrect, right? 95% accuracy. They could identify the image. Computers were only 75% accurate, right? They weren't very good, right? Humans were way better. By 2015, which is 4 years later, when the start of the competition, the computers were 97% accurate. They were actually better than the humans, right? So they don't do the competition anymore, right? so I go, why is that? What happened here, right? This is meteoric, right?
Right.
So there are three fundamental things that are occurring right now. One is we now have a ton of compute available for no money. I made the point, I started a class in cloud computing at Chou University now, about 8-9 years ago. I showed up, my friends at Amazon said, here's $3,000 worth of computer time. I said to the students, well, that'll buy you a computer in Northern California, Virginia, or Ireland for 3.5 years. They all looked at me like, so what, right? I could have a computer in Beijing for 3.5 years. I said, or it'll buy you 10,000 computers for 30 minutes. This is 8 years ago. I mean, we could do math over again. Suffice it to say that $3,000 can buy you a ton of computers, right, at this stage of the game. So the economics of cloud computing are the number one, right? That's been going on the past 7-8 years, and the change has been dramatic in our ability to get a lot of compute horsepower for no money. Number two, these algorithms, these neural network algorithms, which, by the way, have been around for quite some time, right, are now showing up all over the place. TensorFlow is a great example of this, right? So my ability to take neural network technology and deploy it, not as a single node. For those people who've never thought about it, a neural network is trying to emulate how people think our neurons work. So a neuron has a bunch of inputs. There's a weighting function that can be attached to all the inputs. We multiply all together, sum up the answer to those weighting functions times the inputs. And then depending on what the quote activation function is, we fire the neuron. So this concept that these neurons now can be placed in multiple layers, which people refer to as deep learning, we now have the computational horsepower to go do the learning part of this, let's call the learning part of this, in a dramatically better way because we have the compute horsepower. So that's the algorithms are out there. Number two. Number three, the data is starting to be out there. So there's actually a nice graph that Jeff Dean at Google Brain put together, which kind of expresses what is going on out there, which is with neural network technology versus all other approaches, there is a monotonically increasing degree of accuracy the more data I throw at it and the more compute I throw at it, right? So if you wonder, why does Facebook facial recognition work so scary good, right? Well, I don't know anybody else who has more faces in the world than Facebook, right? The AlphaGo, they had 1 million AlphaGo, right, games to study. So the ability now to put more data, more compute, right, against these algorithms, right, is driving increasing degrees of accuracy. And we are seeing this, as I said, whether that's in translation or speech recognition, et cetera. So you could ask, well, so, okay, that's cool. So what does this all have to do with the world of IoT? I go, well, before I go there, I want to make one last point. I know the guys who've been working in this area know this, but I do want to make a point for the people who don't know this, which is the life cycle of machine learning is not the same as a software development life cycle. A lot of us, including me, well schooled on software development life cycles, which are largely what I call deterministic. We know that we want to move money from savings to checking, or we know we want to, identify how many sales opportunities are there, et cetera. These are all deterministic things. But the world of machine learning slash AI slash neural networks is not a deterministic world. It's a probabilistic world. Understanding things like false positives and false negatives, accuracy, sensitivity, trading those off is a very different process of building these sorts of applications and that has happened historically in the world of software development. So if you're not a student of that, go get smarter about that and don't get trapped by thinking about this as the same way that we have thought about building software. So I made the comment, well, why do I care in the world of IoT about all this? That's great for machine translation. Well, I go, look, if you look at speech data, right? What is speech data? Well, speech data is a ton of time series data. Well, guess what? Machine data is a crap load of time series data, right? So is it not now possible to take, right, the same technologies that are being applied to speech, image, et cetera, recognition, and now apply it to the world of machines? And the answer, I think, is yes. This is not going to work by trying to throw all that time series data into Excel and write a report. That's not going to work, right? It's not going to work that we, bring it into our SQL databases and try to write BI, Cognos, pick on everybody, business objects, I don't care, right? That's just not going to be the way. What I like to say, look, I've got 500 sensors worth of data every second from 10,000 machines. What human could possibly, visualize, determine, what to do with that data? This is not possible, right? And so, I think the world, I'm, working with a young software company out here, some of my former students called Laceda, and we're basically building deep learning networks to take, time series based data coming from, large scale machines and be able to learn on it, be able to learn, I like to say, learn from our machines, right? And ultimately create, what I like to think of as precision assistance that based on what they learn from the machines tell people, well, it's time to change the rotor in your wind turbine, or it's time to increase the boost on your turbocharger or whatever, right? Based on learning from our machines. And I think we're still in the very early stages of this, but if what we have seen happen in the world of consumer AI starts to happen here, I think the changes could be dramatic in a very short period of time. So all of you out there who work in this area, keep working at it. Huge
Interesting.
opportunity.
There's one more thing that I wanted to ask you. So you have been observing like IoT industries for quite some time. Like, what are some of innovative startups that you have seen emerging in IoT that you're seeing today? If you can walk us through some of the interesting use cases and some of the interesting technologies that are happening in IoT space.
Let me just touch on it. By no means is this complete. I mean, I think there's a lot of stuff happening at this stage. I'm actually, I made mention, I became the chairman of the Alchemist Accelerator, focused just on IoT. Alchemist is probably one of the leading enterprise software accelerators out there. We like to think of ourselves as the Y Combinator for enterprise. So if any of your listeners are interested, please consider applying, right, to the Alchemist Accelerator. We've had some pretty innovative companies coming out of there. So let me just touch on some things I've seen that are interesting. I think, first of all, I made the comment that the machines are going to be becoming much more software defined, the thing level. I think there's going to need to be a new stack built for things, not for people. There's a young company called Automaton. It's a bunch of what I call GE refugees that started it up, who really are rethinking the stack. I'll call it at the thing level or at the edge level. By the way, I think the edge is interesting because in the world of machines, whether I'm a hospital or a farm or a steam or a utility, I have a lot of different ages of machines out there. Some of them are very modern and talk IP. Others of them have a serial cable connected to them. So edge computing is going to become very important, I think, because we're going to have to find a way to connect all these machines. I think we have the opportunity. I made the point that we could rethink security on things. Things are not going to be changing their passwords every 2 months and adding an exclamation point. So all that IOP technology, I think we need to rethink for the world of things. I'm working with a young company called Unique ID, basically leveraging blockchain technologies to be able to do this, to be able to build a authentication IAM system that's much lower cost and much more secure for things, right? Talk a little about connection. Actually, Friday, I'm having the second meeting of this. We have a project ongoing right now to connect the 500,000 healthcare machines in all the children's hospitals around the world. You'd be astonished at this point in time how primitive it is. We're still sending CD-ROMs around the world. And this is, I think is going to be interesting to be able to do this. Make a point, the consumer internet that we're all aware of, when it hit 1 million machines is about when Netscape, eBay, all this stuff started to happen. And because if you think about it, if it was at 10,000 machines, nobody would care. So it's interesting, 500,000 machines, very interesting inflection point. We're talking about as a vertical internet, looking at using 5G technologies to do this in a private cellular network connected through a backbone, and again, engineering it for security from the very beginning on an end-to-end basis. In the connection world, I'm working young company. I'm an executive chairman for Lucida, a bunch of my former Stanford students, basically taking AI technologies that have been used in the consumer internet and applying it now to learning from our things, redefining a whole new collection architecture that is uniquely tuned to building these kinds of learning applications. I think, again, we have the opportunity to go do this for the first time. Finally, on the do side, the application side, young company out there called Umnitsa. Umnitsa has made a name for itself, basically managing smart laptops and smart cell phones for a lot of famous consumer companies. Pinterest is an interesting example of that. If you start thinking about the fact that, I made the point, the more our things become smarter, the more why is it any different to manage a smartphone than to manage a smart MRI scanner or a smart tractor, et cetera. So that's, I think, is at least has an opportunity to redefine what enterprise, I like to call it enterprise thing management, might be. Finally, this is all going to require more people to learn about all of this. I think branding has been a phrase used largely on the consumer side and largely kind of way after the fact. But I think the opportunity exists right now, whether I'm a young company or I'm building a new digital service product inside an existing company, to start to tell your story, tell the story in a mobile enabled way, tell the story using the modern internet technologies to broadcast those stories, to publish those stories. And so there's a young startup out there called Precision Story who's doing this. And I think it's going to be important for everybody in the enterprise to start moving to, vastly better ways of getting our stories out there. So just a little bit of a highlights of a couple things, at least I've been working in and interested in. But I think there's tons of opportunity out there because, as I've said before, the internet of people is not the internet of things. So things are not people, then we got to have new software to go do this. So.
Interesting. I think that's fabulous. So so one thing I want to know from you is what are the KPIs nowadays that if I am an IoT either professional or if I'm an IoT company, what are some of the leading sort of KPIs that I need to monitor? Like I know it's very business specific in many instances, but there are from your observation, are you seeing like some common KPIs that successful startups or successful companies do monitor in their IoT journey? Like, do you have any thoughts on those?
Well, I think, as a young startup, probably the only successful KPI is called revenue. Whether I'm, building software for things or collecting data or whatever, each one of these, I think, at the end of the day, it's customers, revenue, growth rate are all important KPIs that they need to be thinking about, they need to track. I think on the machine side, the guys that make machines, what I've been telling them to do is I go, look, you need to start breaking your revenue into product and service. And, what is your product service mix? What is the margin on your service business? I know the margin on your product business, but what are the margins on your service business? How are you going to improve the margins on that? Are you still operating in a break fix, world, in which case it's probably, guys with wrenches. Okay, fine. That's not going to have very high margins to it. So I think, those guys, KPIs are really just, service business. How much service business do I have? How much of that service is information delivery, right? And therefore, what are the margins going to be on that? I think those are really the big ones, right?
I think that's interesting. So I think so. We discussed about so the bullish part in IoT, right? So what is happening in the world of IoT? What are some of the interesting things? Do you have a perspective on some of the bearish things? Some of the things that are like either like. Do you have any thoughts on those? Like what is really slow?
I'll do the bearish with you, and then I just realized it's my time. It's 12:20, and I'm supposed to be at a 12:30 lunch. I better get my butt moving.
Okay.
Bearish. I think it's the bearish is adoption. It's adoption. It's the rate. People have asked me, is adoption going to be faster in power versus water versus construction versus healthcare? I don't know. I don't know how to answer that question. I already made the point that, we do operate in the physical world in all of this, right? This is not, financial services operates in a virtual world. By and large, it does not operate in a physical world. So it's much easier for transition to happen in financial services than it is in the physical world. So this will slow adoption. And so the bet that I make, either as a maker of machines or the bet I make as a young startup or, existing company investing in this area is, well, timing is a timing question. And I think you could be bearish and go, it's going to take way longer than we think. And, you might be right. I'm not saying, I just made the comment. It's because of the relationship to the physical world. The flip side of it, and I don't want to use car too much, but look at what's happening in cars. I mean, just go back, 5 years ago, and people thought that was the most, buttoned down, we got it all covered, world. And it's just getting rocked. And so I don't know. I think that's the bearish, the cautionary tale, which is, as an investor, you're cautious of, is timing. And but I think being in the market, and being ready to move, it's not I don't feel like it's something people want to wait on. Is it time to put in, hundreds of millions? Maybe in some cases, maybe not. I think it's case by case. It's going to be, and I counsel people to think about the things themselves, the connection technologies, the learning technologies, the application technology. These are all going to operate in different ways. Most of the investment, by the way, up until now, has largely been in the connection side. That's where most of the investments occurred.
Interesting.
I think so the other areas are right.
Okay. So that's fabulous. And by the way, Tim, thank you so much for really giving us your time. And I'm having a ball with this, and that's why I think it's very difficult for me to let it go. It's like you have been providing so much of interesting insights, and I just want to take it all in this one ginormous session. So we're almost at the tail end of the conversation. So I have like few more, and then we can call it off. So one thing that I do want your perspective on is how much of the IoT and cloud are married together nowadays? Like how much of IoT and cloud is like, are you like, from your perspective, it's too much cloud, or like is that the backbone of enabling an IoT, or you're seeing some, like, what are your thoughts on those?
I think and we're talking about cloud, meaning compute and storage cloud services.
Yes.
I think this is why it's a perfect marriage. I mean, I'm not a big believer in the whole conversation about moving existing stuff. This is not what happened in the world of client server. We didn't move a bunch of AS400 applications, or said a different way, anybody who tried that failed miserably. What is really going to accelerate use is totally new apps, things we've never done before. And that's why I look at the whole IoT space as nobody's got anything over here. We don't, as software companies, we really don't spend a lot of time talking to guys in mining, agriculture, construction, et cetera. And so I think there's enormous greenfield opportunities over there, and it will all be built on top of the cloud. There's just why would you do anything else, right? And that's why I think the two are a perfect marriage. A greenfield set of application opportunities combined with a new technology base that has different economics to it, different capabilities.
Interesting.
Versus just move stuff.
Nice.
Right.
So I want to bring a focus slightly on you. Like, if in your journey, what has been an ingredient to your success so far? If you can share, put a quick thought on that.
Well, I don't know. An ingredient to success is, I think, a little bit of hard work, curiosity, luck. I mean, everybody will tell you luck plays an enormous role in all this, right? So, but one that I keep pushing on is, people should be curious. I mean, be curious about what's next. Be curious. Be a student of the future. And I think the opportunities will open up for you. There's a lecture I give to my Stanford kids. The new world is 10-year cycles, 2 to learn, 8 to execute, and redo again.
Nice.
Sitting in place is nowhere to be anymore, right?
Yeah, I think that's fabulous. So we ask almost every of our visitor about their favorite read. If you can share your favorite read with our audience.
Well, I was going to tell you there's actually 2. So one I just started is it's called Life 3.0 by Max Tegmark. It's pretty fun. It's a pretty fun read. Clearly all about the world of artificial intelligence. The one in fact I just had lunch with my old friend Jeff Moore, and I had not read Zone to Win. Shame on me, but it's a very short book. But anybody into the interesting questions of transformation and incubation inside companies, he has a great model in there, and it's a really fast read. Pick it up, read it.
Awesome. So that brings us to our end of the conversation. And Tim, thank you so much for being so generous with your time. Before we go, I want your parting thought for our audience. Do you have any thought for our viewers or our listeners?
Well, keep listening to you. How about that?
Couldn't agree more. I think that's and Tim, thank you so much for being so generous with your time, and good luck. You're always welcome on the show to share anything exciting, and thank you so much with the time.
Hey, you're welcome. Have a good rest of your day.
Yeah, you too. Bye-bye.
Okay, bye.
I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on the surface.